Part C asks us, what is the concentration of the excess reactant? So in Part A, we found that HCl was our limiting and that aluminum hydroxide was our excess reactant. And so at the end of the process, we have calculated that we would have 0.00375 moles of aluminum chloride. We know that since this was the limiting reactant, we will have 0 moles of HCl at the end, but how much of the excess aluminum hydroxide will we have when the reaction stops? So to do this, we need to figure out, so originally we had a particular amount of moles. We had So to start, we had 0.0135 moles of aluminum hydroxide. We will have used some amount of aluminum hydroxide, and the difference between those two is how much remains at the end of the process. And how do we find how many moles of aluminum hydroxide we used? We do a stoichiometry problem backwards. How many moles of aluminum hydroxide would be required to produce 0.00375 moles of aluminum chloride? Now, this is actually a pretty easy calculation because it's a 1-to-1 ratio. So I want to go, it's pretty much backwards, isn't it? So I want to go from 0.00375 moles of aluminum chloride times, and it's 1 mole of aluminum hydroxide for every 1 mole of aluminum chloride. And so I needed 0.00375 moles of aluminum hydroxide to make the product. And so the difference between those gives us 0.00975 moles of aluminum hydroxide that remain unreacted. The question, though, asks for the concentration of the aluminum hydroxide, and so these two volumes have combined. So we saw that in Part B. We took the 0.00375 moles and divided by 0.120 liters. And so we'll do that same thing because this 0.00975 moles of aluminum hydroxide is now residing in the combined volume of this and this that we started with. So we will take 0.00975 moles of aluminum hydroxide divided by 0.120 liters, and we get 0.08125, but rounded to two significant figures, we get 0.081 molar aluminum hydroxide. So that is about the hardest problem you could do when it comes to solutions, and there is an example of it all worked out.